Hi, this is George Miller from the Buffalo Bill Center of the West in Cody, Wyoming. And today we're continuing our exploration of the Bighorn Basin by looking at the Absaroka Mountains. They're down the western side of the basin, and we'll do it in two parts, the northern part of the Absarokas and the southern. So we'll start with the southern. Welcome to the Absaroka Mountains. The Absarokas are a little bit different than some of the other mountains we've looked at because here in the south, they're mostly volcanic in origin. So the volcanism that created these mountains was massive. It began about 53 million years ago and continued for about 10 million years, till 43 million years ago. So a huge amount of time, but a huge volume of material was erupted. Over 80,000 cubic kilometers or 7,000 cubic miles of material was deposited from these volcanic eruptions. And it's really a huge area, 150 miles long for the whole mountain range, both in Wyoming and Montana. The highest peak is Francis Peak, which is about 13,153 feet above sea level, or 4,009 meters above sea level. So quite a lot of landforms here, and it's an amazing place to think about volcanoes and just how much material was erupted. Now, just for a moment, let's think about stratigraphy. And that's what geologists used to date rocks and to understand their order in a column. So this is a really good example. You can see different layers in the ash bed that was deposited by different volcanic eruptions. And if we can line those up with another segment of the mountain, we can see where they all correlate. Sort of like a giant jigsaw puzzle, putting the pieces back together again. It's quite a job for stratigraphy in geology, one of the main techniques used by geologists. Here is an intrusion, an intrusive dike it's called, and it may be where lava flowed into this mountain and solidified, maybe after eruption or maybe before eruption. So we can see all kinds of things. Oh, here we are. Let's look at these rocks. Now, they may have been created by a pyroclastic flow or lahar, and that pyroclastic flow is when a bunch of rocks are rolled around together and encased in a matrix, a volcanic matrix. Instant replay. Let's take a look at that again. Check it out. You can see other rocks encased in a matrix that's holding them all together. May have been caused by a lahar, which is water getting mixed with volcanic ash and flowing down a hill, or pyroclastic flow, which is hot material rolling down a hill. Well, you can see there are a lot of snow. There's a lot of snow in the Absarokas, and that helps with the erosion. And the rest of the time, we're going to talk about the erosion of this volcanic material because it erodes fairly quickly, water being one of the big erosive forces. Many streams come out of the Absarokas, causing erosion. Well, here's Sylvan Pass. Anyone who's been into Yellowstone from the Cody side has been over this pass, and this pass has been eroded by another phenomenon called an avalanche. In the wintertime, snow piles up and then flows down those steep canyon walls, dragging material with it. And then sort of the granddaddy of them all, the biggest erosive force in our area is the glacier. So this big U-shaped glacial valley shows us evidence of glaciers, and they move massive amounts of rock around. So there are lots of erosive forces working on these volcanic cliffs. It's interesting to think about what might have happened over those millions of years. We could see water has sculpted the landscape. In North Fork of the Shoshone, you can see a lot of towers and spires where more resistant rock is held up and less resistant rock has eroded away. Well, we'll be back next week with more from the northern part of the Absaroka Mountains. I hope you've enjoyed our trip here today. If you enjoy this, like and subscribe to Buffalo Bill Center of the West YouTube page. Thanks and goodbye.